Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar brought to you by TechStrong and WhiteSource. My name is Cody J. Brown, and I'll be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so feel free to send in your questions at any time throughout the program by using the Q&A feature. And we also encourage discussion by using the chat tab. So let us know your thoughts, just say a quick hello, or feel free to talk about whatever we want to talk about today. And finally, at the end of today's webinar, we have a drawing for 4 $25 Amazon gift cards. Stick around to see if you're one of our 4 lucky winners. But on to today's topic. It is best practices for developers, how to easily shift left security. And I'm joined today by Shiri Arad Ivtsan, Director of Product Management for WhiteSource, and Anna Rozin, Director of Research and Development for WhiteSource. It's my pleasure to turn the program over to Shiri to kick us off. Thank you so much for being here with us today.
Thanks, Cody, for the intro. Hey, everyone. Really happy to have you here today. So this is a webinar about best practices for developers. Today, we are going to speak a little bit about our personal story in WhiteSource, how we succeeded to easily shift left security. So today with me is Anna. Hi, Anna.
Hi, Shiri.
And we are going to discuss a little bit on how we actually managed to move from DevOps to DevSecOps. And we actually see this quite a lot in organizations, right? So we all know this DevOps eternal cycle that starts with planning and ends in monitoring. But it's really hard to put security in here, right? It's nowhere in here. And the DevSecOps approach basically just says that the security part is in every little step here. So there is part of security in planning, in coding, in building, in testing, releasing, and everything else. And this is actually what we try to implement and also how we try to build our tools and use our tools. So this is really how we manage to do it ourselves.
Yeah, so it's really all over the place, and developers really feel it from the beginning, where they search for some open source component till they release something to production.
And we are actually looking right now at the traditional way of handling security vulnerabilities. And this is what it used to look like in our organization. So we have our security teams, and they would analyze and prioritize the different vulnerabilities, right? Some of those vulnerabilities are coming from open source components. Maybe some of them are also from proprietary code. But eventually all of the application security issues. And they would either send emails, in our case, they would open Jira tickets for the developers, and at the end of the day, the developers are responsible for fixing the issues. But they sometimes do, and sometimes they can't for some reason. So let's say it's not that easy to upgrade that component because it breaks something. Or there is a security vulnerability, but currently it's not prioritized in the sprint. So closing the loop on the resolution, like really understanding security teams needed to understand what was remediated and what is the current risk. And this was pretty hard for us, at least.
Yeah, I also think that when the developers kind of start to be involved in the process and they really feel the meaning of that and how important is that, they kind of try to cooperate and they want to fix it because they understand the reasons and why it's so important to do so.
Right. So we actually understand that once we just, throw those tickets at them, like you need to fix this, you need to fix that, it doesn't really provide like the ownership that we wanted. And this is really all about like processes and cultural change and the ownership. So our solution, as we mentioned, was to integrate DevOps, which was already implemented in our organization, and to integrate that with the security culture. And as you probably know, with DevOps, sometimes security can hold you back, right? So some security teams would say, yes, I want to manually approve each and every component before it goes to production. And this is really like against the entire concept of DevOps and Agile. We all want to be like very fast. We want to give the business value that we need. And security is sometimes holding us back. So this is why we had to sort of take the security aspects and integrate them into the DevOps processes. We try to use all kind of methodologies to deliver small and very secure pieces of code in frequent releases. And we really tried to automate everything whenever that was possible.
Yeah, and well, how we really did that. So let's go over a few steps.
Yeah, so we started with understanding what are the current processes that we have in our organization. And we managed to understand that, of course, we first need to detect the vulnerabilities. This is the basic step. After that, we would usually prioritize the vulnerabilities. As you probably know, an average application would have like hundreds or even thousands of security vulnerabilities. And we really knew that we wouldn't handle all of them, at least not at the beginning when we just started. So we had to really prioritize and understand what we're doing in each and every step. The next thing was to inform. So we wanted to make sure that the developers or the specific person that needed to handle this vulnerability is actually familiar with it. And then we had to remediate it and also prevent it. And above all, we're trying to do everything within automation. So we try to automate every step that we can.
Yeah, I also think that even before detecting those, there is some kind of cool tool that we are using. It's open source, and basically what it does, it suggests the developer to upgrade his dependencies version, not because there is a security vulnerability, but because there is a newer version. There are some maybe bug fixes. Maybe the upgrade will also fix some security vulnerability, but let me show some small and quick demo for that. So this is some demo project that I'm using. And it's Maven project, nothing special. It has a POM file. It has 4 dependencies here. And it also has 6 pull requests. As we can see, all the pull requests are from Renovate bots. And if I'll go to one of those dependency, let's say Commons collection, I can see that basically Renovate suggests me to upgrade the component. It's minor fix, just from 3.2.1 to 3.2.2 version. The adoption rate is 66%. There is a confidence level, which is high, so I can feel really comfortable with doing this upgrade. It also shows me what should I do. I can review the change, approve it, submit the review, and just merge it to my code. So I think that whenever a developer just upgrade his dependencies, he may prevent the vulnerabilities because he will just have the newest version that still doesn't have any known vulnerabilities, at least.
Exactly. So like dependency hygiene is one of the definitely the best practices when managing, open source components, making sure that you are always up to date. One of the interesting facts about open source and like the open source community is that once a vulnerability is being published in like, I think the latest number is like 95% of the cases, it's published with the fix. So that means that if we're always up to date, we will have a lot less vulnerabilities, and we'll also have the most update functionality. So this is something that we really use, I think, today in all of our projects. And so this is just a glimpse on what we do to manage it within GitHub. But I think that we went ahead and we tried to understand what are the different processes that our developers go through. And we understood that the second one, right after researching a new component, would be writing the code in the IDE. And here we also have a small demo.
Yeah, so I just want to mention that even before showing the demo, the idea to create an IDE plugin that detects the vulnerabilities while writing the code in the IDE itself was of one of our developers. So it's really cool that you see that your developers are in the process. They want to fix, they want to do stuff. And if I'll go to the IDE, we can see here that I have the same project that we saw before. It has these 4 dependencies, and we can see here that there are some marks, some red, some orange, some yellow. And I will go to the red ones because most of the times it would be the most crucial issue that pops up. And I can see here that this dependency has actually CVE. It has 4 CVEs since I have 4 marks here. And it also tells me that I can upgrade the version to fix the vulnerability. I can either choose version 3.2.2 that we saw before. So if I just was upgrading this before with Renovate, maybe I wouldn't even know about this vulnerability. But I can also check some higher version, but this could be very hard to fix because maybe I need to change a lot of code. So as the beginning step, I just would try to upgrade it to 3.2.2. And what happens now is basically that the plugin itself rescans the POM file, and it will actually check again if I have vulnerabilities or not. And as you can see, the mark has disappeared. This component doesn't have vulnerability, and I kind of can feel safe, and I can go to fix other vulnerabilities that I have here for those other 3 dependencies.
Yes, and this is really a great example because think about like the slide that we showed about the traditional model, right? The developers would have seen it like so late in the process. After the code is already there, they're already using that component, and going back to that code, changing it, modifying it is sometimes very hard. Well, once I develop, I added a component, I just go ahead and change it. This is a lot easier. And these are exactly like the small pieces, like agile pieces that we add to the processes. And the next thing I think is about policies or how we use things to sort of govern. So we are speaking today a lot about developers, but of course, security teams have a very important role in, of course, implementing this methodology, but also setting all kinds of organizational policies, or even policies per application or per product in order to make sure that the developers actually comply with them.
Yeah, so basically, let's see some small demo of how I'll create a policy in WhiteSource application. And this is just my WhiteSource application. It's just my home dashboard. And I have here 4 projects. And now I would like to create a policy. So let me just sign in. And whenever I'm signed in, I'm going to create a policy for my whole organization. I don't like my developers to have high security vulnerabilities. So I would like to select by security vulnerability severity. I don't want to have high security vulnerability, and I would like to actually reject them. I will add this policy and save it. So now all projects in my organizations will have such policy whenever they use WhiteSource scanner. And if I'll go to this Jenkins job that basically used the other project that we saw before, and we already know that it has more than one vulnerability. And I just run it now to make a build for this project, and now it's actually running. So in a few seconds we will see what happens here. So now it runs the scan with all the parameters, and we actually see that there is a policy violation. The exit code is -2 with actually failing the job, and you see here that the job has failed. So even if I would like to move my code to production, I would like to deploy it, there is no chance I can do that because the job is failing and nothing will continue forward.
Exactly. And just to mention, this is sort of our last resort, right? We don't want to fail builds for developers. We don't want to have all these kinds of we're completely stopping them from moving. This is why we try to do it as part of the development process, as part of the repo. But sometimes if this is a gate and I'm about to deploy to production, it's better to fail the build than sort of have a high severity vulnerability in production, of course.
Yeah, and can always pop up later, even though yesterday we didn't have vulnerability and now we have it. So we need to handle it.
Exactly. So the next thing we wanted to discuss is really the prioritization. So how do we make sure that we really treat the things that are most important and most critical right now? And at the end of the day, managing security vulnerabilities and security in general is all about managing risk, right? You want to manage and you want to make sure that you don't currently have a too high risk. And what we try to do is, of course, we always have sort of the naive approach of prioritizing based on the CVSS score, or treating the high ones first and then the medium ones and then the low ones. What we try to do usually in WhiteSource is to take multiple parameters into account. So not only the severity, but also the availability of fix, right? Is there a fix? Is the fix in a minor or a major version? And also, what is the business impact? We know that some of our applications are being distributed, let's say, to on-prem users, which is, of course, more dangerous than having something that is internal, only running within our VPN, and is maybe like an internal application that we don't distribute and don't deploy. So in that case, handling vulnerabilities in the external application is much more important, and it will be prioritized as it is.
Yeah, and we also have some other tool that actually can help us to prioritize our vulnerabilities fixes. So there is a tool named Prioritize, and what actually it does, besides the fact that we know that we might be exposed to vulnerability if we are using some component or another, it also tells if there is actual reachable trace to this vulnerable code. And if I'll show it in a WhiteSource UI, we actually can see that for one of my projects, I have here basically 8 vulnerabilities, but I also have shields. I have red ones and green ones. So the red ones means that not that only that I have vulnerability, that I have actual reachable trace to the vulnerable code. So I'm actually exposed, and I really have to fix them no matter what is the severity, I really have to fix those. But the green one says that, yes, I have this vulnerability because I'm using this kind of open source, but there is no reachable trace from my code. So in terms of compliance, it won't work, but still, if I need or have to prioritize what should I fix first, because I have 8 vulnerabilities in the same project, I can start with the red ones for sure, and then see what can I do with the green ones.
Yes, and just to mention that the ratio that we see in like average projects between the reachable and non-reachable is like there are around 80% that are not reachable. So this really helps us to focus on what is really matter right now to my application.
Yeah.
So in terms of remediation, how do we do it? And Remediate is another tool that we use that was developed in WhiteSource that allows us to fix the vulnerabilities, and it actually opens an automated pull request with the fix to the specific vulnerability, and it actually suggests an upgrade to the open source component in order to resolve the vulnerability. So it keeps on and checks my dependencies to see what dependencies have a higher version that's released that also solves the vulnerability. And we can actually see here, for example, this is an example repository that I have. We can see that WhiteSource actually detected a medium severity vulnerability in one of my open source component. We can see the vulnerable library. In this case, it's a direct library. And we can see all kinds of details about the CVSS score and what's the suggested fix. And in addition to that, we can also see that I have a pull request, and the pull request was opened by WhiteSource automatically. And it really suggests me to have an upgrade to version 4.0. This is, of course, a major upgrade, but I can say that it also eliminates my vulnerability. So now it's up to me as the developer either to use the merge confidence feature that we saw before to perform all kinds of automated tests and basically to decide if I want to merge this or not.
Yeah, and I think also having good unit tests can really help in the decision of, do I want to take this fix or not? Since if I have this good unit test, I can upgrade the dependency and just run my unit test and be more sure in this sort of fix. Well, the next thing that we didn't really talked about it before is transitive vs direct dependency. As we all know, when we bring some open source component, it brings with themselves some other open source components that become transitive dependencies of our code. So what actually we can do with transitive dependencies vulnerabilities. So sometimes it's really impossible to fix them, and we might need to end up with changing the component that we are using, the direct one. But sometimes it is possible. Sometimes upgrading the direct dependency to some newer version will fix the transitive dependency, because this open source also wanted to fix its vulnerabilities, and it upgraded the child dependency, and now I can have the benefit of upgrading the component. Sometimes I can bring on my own the transitive dependency with the right and correct version without issue. But sometimes there is no way to fix it, and we really need to be aware of that transitive dependencies and not only the direct ones.
Right. So for those of you who are hearing this webinar, you may say, okay, so since, open source components have a fix if a security vulnerability was detected, then it's pretty easy. I would just, open that pull request and merge it automatically and everything will be good. And of course, it's not the case. It's much more complex than that. A lot of that is definitely due to these transitive dependencies, and this is something that you definitely need to take into account. Okay, so we're really towards the end of the webinar, and we wanted to share with you some takeaways from our process on how that may help you to implement this in your company. So I think we mentioned it before, but again, cultural change is the key to success. Like the fact that, me, a product manager, and Anna, like director of R&D, are currently sitting and speaking about the process that we went through is really because we don't think this is the security team's problem, or this is the CISO's problem, or this is someone else's problem. We definitely understand that if there is a security issue, it's on us. It's on me because I prioritize the tickets in the sprint. And if I didn't prioritize a security vulnerability, it's a very big risk that I need to take into account. And of course, Anna needs to have the right processes in place to make sure that everything is implemented as it should. And the second thing, and they think we couldn't do it without it, is that automation is the main driver, right? Because we couldn't handle all of this, just manually. So this is another very important takeaway.
And yes, also it is very important to try to do it as fast as possible, the fix, but also as soon as possible. So whenever we search for a component or even starting to write the code, if we see a vulnerability, we should fix it right now, or even prevent using a component, since if it goes to production, it might be much more difficult to fix it. We will need to refactor our code. So as soon as possible, minimum actions, and it actually could really help. And also keep our dependencies up to date as much as possible to even not see those vulnerabilities.
Yes. And I think if we can summarize, so there are so many things that developers need to take care of these days, right? And security may just seem as, it's another thing that I need to take care of, but really it's very different than that. So once you put the ownership on developers, but you also give them the right tools, right? You don't bombard them with like thousands of vulnerabilities. You just help them within the IDE, in the code that they wrote, to understand what security vulnerabilities were added. It becomes a lot easier. So I think with that, we will wrap it up for today. Thank you so much, Anna, for being with me.
Thank you, Shiri.
And Cody, back to you.
Outstanding. Well, thank you so much, Shiri and Anna, for taking the time to be with us and putting together your demos. Any questions that we were unable to address today, we will be sending over to the folks at WhiteSource, and they'll get those answered for you as soon as possible. A quick reminder that today's session was recorded, so following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website. You can just visit devops.com/webinars and look in the on-demand section. Now on to the 4 winners of our $25 Amazon gift card drawing. Our first winner is Kunta H. Our second winner is Kathy P. Our third winner is Melissa H. And our fourth winner is Alexi B. Congratulations to the 4 of you. Please keep an eye on your inbox to claim your gift card. And if you don't receive an email, just check your spam folder. Again, Shiri and Anna, thank you so much for taking the time to put together this program. And I'd also like to thank you, our audience, for being with us for the entirety of the presentation. This is Cody J. Brown signing off. Have a great day, everyone.